All right, this is lesson 7 of Unit 2, topic 1, and in this lesson we're going to be learning about linear and exponential functions and what they look like. So it's our first real look at comparing graphs of the two. Today's warm-up says write an explanation comparing and contrasting a linear and exponential function. So if you look at these two functions, you can clearly see that the linear is increasing and the exponential is also increasing. They're both increasing. But the linear is increasing at a constant rate, and the exponential is increasing at a rate that is growing. So you can see here that it's actually below the linear, and then it passes it right here. So they become the same at one time, and then the exponential increases a lot, really fast. So the exponential is increasing at a greater rate as time goes on. It's always going up faster and faster and faster. All right, so that's the kind of things I would have written. This is basically just talking about the exact same thing. So you could say that the similarities here are that they both are increasing. The linear is increasing at a constant rate, and exponential is increasing at a greater rate as time goes by. There's a lot of other things that you can mention, like this is curved and this is a straight line. Anything that comes to your imagination, you can write down. So in this lesson, we're talking about Allie and Dane. And Allie and Dane are at a water park, and they're trying to fill up they're trying to drain each of their pools. So using a pump, they're trying to remove the water from the small pool on the bottom of the ride. So here's Alan. So things that you should have noticed when you look at this graph, because that's what it says. Record some observations. So some observations I noticed is that Alan's pool started with pool started with more water. You can see that it clearly starts above this one. This is Dane's pool. Dane's pool took longer because this is time. Allie's was able to finish first. And you should also know that Allie's goes down. They both go at a constant rate. That's a similarity. But Allie's is going down quicker. So even though her pool started with more water, her pool drained first because her pool is going down quicker, whereas the red line you can clearly see is not going down as fast. All right, so based on this new information, correctly label the graph above. For what values of x does this is in this situation? Dane figured out that the pump he uses drains the water out at a rate of 1,000 gallons per minute and takes 24 minutes to drain. For what values of x make sense in this situation? Well, it takes 24 minutes in order to drain. It takes anywhere from 0 to 24 minutes. X can be anything in between because after that it's finished draining. Determine the range or output. Okay, well the highest it ever goes is 1,000. So the lowest it'll ever be is 0 and the highest it'll ever be is 1,000. And I believe that was D of T if I'm not mistaken. I can go back and double check myself. It was D of X. Okay. So yeah, I would change that to D of X. All right. Next question. Based on the graph and corresponding equations for each of the pool, answer the following questions. When is A of X equal D of X? And what does this mean? So when are they exactly equal? So if we look at the bigger graph right here, it looks like. So what we need is some increments. And they have given us some information. They have now told us two things. It took 24 minutes in order for Dane's to finish draining, and it also had 1,000 to begin with. So if Dane started with 1,000 and it took 24 minutes, now I can figure out the rest of these increments. We do know that this is 0. 1, 2, 3, 4, 5. Okay, 24 is here. This looks like it would be about 25 right here, which means 25 divided by 5 increments means each one is 5. We've now established that. This is 20. 24 is close to, 25, which is at the end. All right, so now going the same way here. So that's 1, 2, 3, 4, 5, 6. It took 6 increments to get to 1,000. Okay, that's a weird amount of numbers. 1, 2, 3, 4, 5, 6. Okay, I wish I had a graphic calculator on me right now. Let me erase this and just make sure that the 1,000 is right on the line, and it does look like it's on the line. So this seems like a mistake to me. 1, 2, 3, 4, 5, 6. Because the reason why I'm stalling here is because 1,000 divided by 6 is going to give us a weird set of increments going up. So for the time being, I'll tell you what, I'm going to hold off on that. I have confirmed that the bottom definitely is going by 5s. We have definitely confirmed that. So it was 1,000. Let me check. Yeah, it says 1,000 gallons. Oh, per minute. I was missing that. 1,000 gallons per minute. That makes more sense. Okay, so if it's going 1,000 gallons per minute, that means it went 24,000 gallons altogether. All right, and the reason I know that is because it took 24 minutes. 1,000 gallons per minute means it was 24,000 gallons to begin with. This is making a lot more sense now because this was 6, and 6 goes into 24,000 equally. That means each one's going to be 4,000. This will be 8,000. This will be 12,000. 16,000 and 20,000. Perfect. And that means that this is going to be 28,000. All right. So now that we've logically thought that through, we're ready to go back. When are they exactly the same? And what is A of 10? I'm going to go back for 2 questions now. When are they the same? It looks like they're the same at 10 minutes. And A of 2, is that what it was? A of 2 would be about 27,000. I think that's what the question was. Oh, it was A of 10. Okay, so it took 10 seconds for them to be the exact same. That's what that means. I'm not going to write that down. A of 10. A of 10 is, what is that? That looks like about 14,000. All right, next question. If d of x is equal to 2,000, what is x? When is d of x when? So what is the x when d of x is 10,000? Boy, I really should have copied that. Oh, 2,000. I'm forgetting the questions. All right, so 2,000 is all the way down here. D of x is 2,000 right around here, which I'm going to just estimate that's about 22 minutes. It takes 22 minutes for d of x to be 2,000. When is a of x greater than d of x? Okay, so a of x was greater than d of x at the beginning. This entire piece, anything to the left of 10 minutes. So anything less than 10, so when x is less than 10 is when the a of x is above the d of x graph. All right, so getting to the homework. In the lesson we just did, probably you're going to have some time to do this in class because the classwork wasn't all that long, and the homework is very long. So the domain here is from -5 to 5. Domain means the x value, the independent variable, which means from left to right. Range is from bottom to top, or top to bottom. You can do it either way you want. Domain, I usually think of least, which is -5, to the greatest, which is +5, and x has to be anything in between. Because this is a continuous function, you have to give the range of the domain. Ooh, I shouldn't say the range of the domain. I should say the interval of the domain. The range in this case goes down to all the way down to -6, and the highest it goes is +2. And f of x has to be in between. I'm using f of x because that's what it told me in the graph. I'm going to always use what they give me. The domain of this function, it looks like it's going infinitely to the left, starting at 4. So x can be anything less than or equal to 4 because it is a closed dot here. The entire function is pointing to the left, infinitely. So I'm not going to use, you're probably wondering, why didn't I use a compound inequality? It's because this is only going infinitely in one direction. There is no stopping point to the left, so I'm not going to say it's between these two numbers. It's everything to the left of 4, including it. Range. The range in this case is a lowest point of -6, and let's see, -6 is less than or equal to f of x. And the highest part, I don't know if we've talked about asymptotes yet. Asymptotes is a silly sounding word, which basically, it's a math word that represents the line in which it'll never reach. This line will go to the left and up infinitely. I know that's a hard thing to grasp. It's going to go up infinitely, but yet it's never going to reach the 0 line. Now, I'm not going to put or equal to because it's never going to reach that 0 asymptote. So, yes, this line is going to go to the left infinitely, but it's also going to go up infinitely, and it's never going to hit the 0 line. It's going to keep going up, but you'd have to keep zooming in closer and closer to this x-axis to see it going up. That's a very, very, very tough thing to teach or understand. Is this function increasing or decreasing? This function is decreasing. This function is also decreasing. You always look at a function from left to right. I know you're thinking that it starts here and it goes up. No. Functions are always looked from left to right, and this function is actually going down. Don't follow the way of the arrow. The arrow just means it goes that way infinitely. That doesn't mean that that's the direction that you follow the function. That's very key, and I hope you're watching this video. Because if you're not watching this video, you're probably not going to get that. The domain of this function, okay, this is a silly thing for me to explain to you, but this actually does not have an asymptote. This is going down and to the left infinitely. And it's also going to the right infinitely. So the domain here is all real numbers because it's going both directions infinitely. Therefore, every single number on a number line is a possible domain. The range does have an asymptote, and this is something you're going to talk more into when you get to Algebra 2. But for right now, I'm just going to basically tell you that this has a height possibility. It looks like it just goes just above 4, which means it'll never reach 5. And the lowest it goes is infinite. So you know what? I'm not going to use a compound inequality because we don't know one of the direction. One of the directions goes down infinitely. So what we do know is that f of x has to be below 5. It'll never get to 5, and everything below 5 is a possible range because it goes down infinitely. Is this function increasing or decreasing? It is increasing. The reason I know this is because you look at a function from left to right like you read a book. The domain of this one is from 1 to 6. It does have endpoints, so I am going to use the compound inequality. The range of this function goes down to -2, and it goes to a height of -1. And f of x can be anything in between or equal to. Okay, so this is -2 is less than or equal to f of x, which is less than or equal to -1. Sorry about the bad writing there. And this is increasing because you can clearly see from left to right it's going up. All right, next question. The domain of this is going infinitely in both directions. So this is all real numbers. All real numbers. Yeah, it's kind of cut off down here, so I'm going to make you have to watch the video here. Sorry. In fact, I'm going to just erase all of this. This is all real numbers. The range, the height, is also going up and down infinitely, so that is also all real numbers. This function is increasing from left to right. The domain of this one does have an endpoint here. So the domain in this case is going to be x is greater than or equal to, because it's a closed dot, and it looks like -5 if I'm not mistaken. The range, this looks like it's about 4, 3, 2. There's 1, so I'm going to say about a half. So it looks like that f of x has to be greater than or equal to a half. I'll say that again. So the reason why it's a half is because you go across here, it looks like it's in between 0 and 1. So there's where the domain is lowest point. It has no highest point. So that means f of x can be anything greater than or equal to a half. And that function is also increasing. All right, 13 minutes. This might be one of my longest videos. Thanks for watching, and I'll see ya